All right, we're going to look at analyzing functions, graphs of functions today. And example 1, use the graph of the functions to find the domain and range of the functions, then find the indicated values. So for the first one here, when I look at the graph, what's the domain? Well, you scan, your x's are here, so do a quick scan and see which x's are represented here. Which x's do you see? If these go on forever and ever and ever, your domain is going to be what? All reals. You could write it like that. You could also write it in interval notation like that. Either way. Range. Well, do a quick scan up and down. What y values do you see here? Well, this is what value right here? That's -3. So y is what? Greater than, is it equal to? So y is greater than or equal to -3. You can also write it as interval notation, -3 to positive infinity.
Where's the y in the x spot?
This is not an ordered pair. This is interval notation. And since I'm telling you it's range, I know that it's the y values. All right, what's f of -3? So now we go to -3. 1, 2, 3. What's f's value here? Looks like that's -2. What's f of 0? It's 0. What's f of 2? Let's just say it's at 3. Questions there?
How are you finding those out?
Well, where's my x2? Right here's x is 2.
Yeah.
So I go up to my ordered pair. What's this ordered pair? That's the ordered pair 2, 3. So f of 2 means what's the y value that corresponds with the x value. Okay, for the next one, what's your range here, or what's your domain? Oh, let's fix this a minute. I didn't mean to do that.
You meant to go the other way?
I want the graph to stop right there. This graph to stop right there, sorry. So now we're going to do a quick scan of our x's. Well, this goes on forever this way.
What's that point where it stops?
What's this point? 6, 6, 5. So what are your x values? Well, they're all x, what? Less than or equal to 6. If I wrote it in interval notation, it'd be -infinity to 6, and I include 6. You do interval notation, the smallest number comes first, the larger number comes last. What about your range? Well, right here, y is what? Y is equal to -5, and what else? between 3 and 5. So y is less than or equal to 5, but greater than or equal to 3. I wrote it back. I was reading it backwards. Y is less than 5, but y has to be bigger than 3. There's an open circle right here. So that means 2, negative 5 isn't included, but negative 5 is included everywhere else here. So negative 5 is part of my range because it's included in these other ones. So then what is f of negative 3? How about negative 5? What's f of 0? There's 0. There's. What's f of 2? That's order paired 2, 3. So it's 3. Questions there? Okay. When a function is represented graphically, we use the vertical line test to decide if it's a function. I think, did we talk about this yesterday? We had the circle x squared plus y squared. We talked about the vertical line test yesterday. The vertical line test line crosses the graph more than once. The graph does not represent a function. And then the zeros of a function are the x values that make f of x equal to 0. Well, if f of x is 0, what's another name for zeros? If y is 0 and we solve for x, what are we finding? What? X-intercepts. So zeros are the same as your x-intercepts. Also, when you write zeros, do not write as ordered pairs. When I ask you to state the zeros, you just state the x values only. So, find the zeros of each function below. Well, when will this function be 0? It's an x squared function, so what do I have to do to solve it? We need to try to factor it. So I'm going to use that bottoms up method, rainbow method, flip slide or something. I came up at a meeting I was at. Is that 48? Oh, how about minus, not equals? Now, what multiplies together to give us 48, but subtracts, it's a subtraction here, to give us 22. 24 and 2. Which one's going to be positive?
24.
24. Why?
Because 22 is positive.
Because 22 is positive. So we multiplied by 3, so we need to undo that. So we need to divide by 3. Well, 3 goes into 24 nice and neatly. 3 does not go into 2, so I bring that up. And now your zeros are what? -8 and about 2/3. Add 2 divided by 3.
Bring the 3 over, it can't be divided.
Questions there? How are we going to find the 0 for B? For B, letter B, example B. Not yet. It would be, but how do I prove it? How do I show it? Match.
Just write X. You put 0 over left side of the equal sign. Add 3 over there.
There you go. We're finding 0, so we put a 0 in. We add 3 over. Then what?
Square it now.
You square it. To get rid of that square root, we've got to square it. So we get x is 3. C, h of x equals x squared minus 4 over 5x. So we set that equal to 0. When will a fraction be 0? That's not true. No. Not when it's undefined, it's undefined. When will it be 0? When the numerator is 0. Remember, I could take 0 and divide it by anything. So it's when the numerator is 0. Well, when will this numerator be 0? X squared, add 4 over, square root. Don't forget that negative 2. Because when I take a negative 2 and square it, I still get 4.
Where'd you get the 5? Where'd you do the 5?
5 is the bottom of the fraction. When will a fraction be 0? When the numerator is 0. So the denominator has nothing to do with our problem. Now what we want to do is we want to check to make sure these answers don't make our numerator 0. When I plug in 2, make my denominator 0. When I plug in 2, what do I get at the denominator? 10. Plug in negative 2, negative 10. All right, what you need to do now is one person from each group go back and get calculators for your group. Now, a couple of you have some, yours, so
Don't worry, I'll get it, guys.
graphing calculators, guys. Graphing calculators.
Where's my stick? Holy charge. We're one short.
All right. After Labor Day weekend, we will come in and we will do a lesson on how to use these graphic calculators. We're going to start with it today. I will remember, if you are short in your groups, share right now. I'll make sure I get another set in here. But when I look at this problem right here, if I try to factor it, when I factor out a greatest common factor, it's x squared. That gives me x minus 3, which isn't going to match up over here. So what we're going to do is we're going to use the graphing calculators to find our zeros. To do that, up here in the top row, whenever you're graphing, you're going to use the top row here for all your graphing needs. Right up here at the top. So where you see y equals, hit y equals. If there's something in there, clear them all out by just arrowing down and hit clear. Y equals. Everybody have them cleared out. Charlie, are you using yours?
Yes.
Or are you going to sleep? You're going to use it, huh? I mean, it's up to you. You're not going to use it. Others are going to have it.
I'm playing Pokemon.
All right. So, in that space, you're going to type the equation. To find the variable is right here. See where it says alpha, the green alpha button? Right next to it is x, t, theta, n. There's where you get your variable. So hit that. I need to cube it. Caret key right here. 3 will cube it. Make sure you get out of that. And then minus. Use the minus key, not the negative key. Use the minus here. Minus 3x squared. And you can just use the x squared key. Minus x plus 1. Everybody have that in. The caret key.
Let me get that.
All right. Anybody else need help getting in?
I know.
All right, up there at the top, you see graph, hit graph.
Oh, wait, that's not on mine.
Okay. Some of them look different than mine. Don't mess with yours. Just wait a minute, please.
Why is mine not? She can't see me. Maybe it's the Zoom.
Alright. So yours looks different than mine. Alright. Mine looks a little bit different. I have a window. I put my window, and if you hit window, you can see my window says that I'm only graphing between -1 and 1. So I'm going to hit zoom 6. That takes me to the standard graph. And now it looks a lot different than yours. So everybody hit zoom 6. Zoom is right here, then hit the number 6. And then all of our graphs will look exactly alike. How many zeros does this have? It has 3. Cross that x-axis 3 times. To find the zeros, shh, guys, you really need to pay attention in order to know how to do this. In order to find it, again, whenever you're dealing with the graph, you're using this top row of buttons, and I need to calculate. So I need to get to the blue, so I hit second calculate. What are we looking for? We're looking for the 0, so hit 2. Read at the bottom what it says. It says left bound. See that flashing cursor?
Who's calculating? It's right under trace.
Hit second trace. Top row,
I hit second.
and then top row. Whenever we're dealing with, we look up here. Calculate. So then we're looking for 0. So you hit 2. Now, this arrow, you need to put it to the left side of the first 0. We're going to do it 3 times. So I'm going to move my arrow using the arrow keys till I'm below the x-axis. And hit enter. Then it says right bound. So I'm going to move it till I'm above the x-axis. Hit enter. You can see it put 2 dots in, and it put where the 0 is. The 0 in between those 2 vertical dotted lines. There's the guess. It says guess question mark. Hit enter again. It tells us what the 0 is.
How'd you move it up?
So round it to 3 decimal places, -6.75.
How did you move it up?
The arrow keys. These arrow keys right here.
Why is mine not going?
The right ones. Did you find it?
Yeah, but it's not going up.
Do right to left.
Okay. So which way are we going?
You want to go left bound, so you gotta be over here. You gotta be the left side. There you go. Anywhere. So
I just pick a number.
are you going to the left of the 0? Hit enter. Now you gotta move it to the right, so you gotta move it so it's above the x-axis. Perfect. Hit enter. And hit enter.
Ah, okay.
All right. Now we're gonna do that for the next one.
I don't know what happened. I had it right and then it just went the wrong way.
I have no idea. All right. So hit second calculate. You're looking for the 0. Now I've got to put that arrow to the left of the next one. Well, if it's flashing there at the top, is it to the left of that 0? Yeah, the 0 is right here. That flashing is to the left of it. So hit enter, move it to the right, so that now the right is now underneath. Hit enter. There's where we guessed it. Hit enter again, and we get a 0 of 0.461. And now we have a third one. Second, calculate, 0. I'm to the left, I'm to the right, hit enter again, and you get 3.214. All right, do not take it out of this graphing calculator because we're going to come back to it in just a minute. All right, so just set the calculator aside. And now let's look at increasing and decreasing intervals. A function is increasing on an interval if x1 and x2, x1 is less than x2 implies it's increasing if it's rising from left to right. So what's increasing function look like? It's increasing, it's rising from left to right. It's decreasing if I'm falling from left to right. Okay, increasing as you read books from left to right, we read graphs from left to right. If it's rising, it's increasing. If I'm falling, it's decreasing. A function is constant on an interval if x1 and x2, if f1 of x1 equals f of x of 2, constant means it's a horizontal line. All right? You have a minimum value where your graph goes from decreasing to increasing. We have a minimum value. We have a maximum when I go from increasing to decreasing. A minimum, a relative minimum, is what the low point on that graph, the valley. And the relative maximum is the peak, it's the height. So what we're going to do now, for example 4, is we're going to go look at that function we just did. We're going to find the relative minimums and the relative maximums. And then we're going to graph it. Well, what part of this function do we already know? We know the zeros. The zeros we just found were at negative 6.75. About here, 4 point something, about here, and 3.2. Oops, a little bit more. So let's go back to the graph. Go back to y equals. If you just hit graph again, it'll take everything we have off of there. So where's the relative maximum point at? Where's it at here? Well, it's somewhere right here. Right there, right there. So if you hit second calculate, what do you see there? You said maximum minimum. So let's find that maximum. That's number 4. Again, we take that cursor and we put it to the left of the maximum. Hit enter. Put it to the right. Hit enter. So that that maximum point is in between those two dotted lines. and there's where we guessed it. Hit enter again, it tells us where our maximum is. So you should have got a max.
Can you move the paper down? So you can't see?
At negative 0.155, comma 1.079. Is that what your calculator says?
Yep.
So now find the minimum. Again, second calculate. We're going to hit number 3 this time. And I need the cursor to the left of the minimum. I need it to the right of the minimum. Again, it doesn't matter where you put them, just so they're on right to left. Hit enter. You should get a minimum of 2.154, comma, negative 5.079.
Do we not have to round?
Just a little, yeah, 30,000 places is good. I just kind of quickly threw this graph up here. It's not exact by any means. What's that? All right, I just threw this graph up here because where is it increasing? Well, it's increasing from here to right here. So it's increasing from negative infinity to the y value of this maximum. Wait, it's x value, sorry. X value, it's increasing from here to here. Is it increasing anyplace else? Yes. From here to here. So this is the minimum, the x value, 2.154 to positive infinity. Again, these are not ordered pairs. These are interval notations. I don't include the maximum or minimum. You do parentheses. And then it's decreasing from where? Here's the decreasing part, which is from negative 0.555, comma 2.154. Questions there? On your homework, I'll tell you which ones you're going to want to do before you leave, because you're not taking graphic calculators with you because I need them for next period. Questions there? Anyone not done? The average rate of change between any 2 points of a function is the slope. It's also called a secant line.
Can you move your paper, please? Thanks.
So the average rate of change is the slope between 2 points. If it's not a straight line, that average rate of change is going to be different. So we want to find the average rate of change on this parabola between 1 and 5. So I have one ordered pair. I know the x of each ordered pair. How do I find the y values for each? Plug them in. So 1 minus 2 plus 8 gives me 7. 25 minus 10 is 15, plus 8 is 23. And now your average rate of change is your change in your y's. And you get 16 over 4, which you get 4. Question?
Yeah, what do you do?
I just found the ordered pair for each of my x values. x1 is 1, x2 is 5. That means I plugged them into the original equation. I found f of 1. I found f of 5. So 1 minus 2 plus 8. When I plug in 5, I get 25 minus 10 plus 8, which gave me my two ordered pairs. And then I just found the average rate of change. Questions? All right, last thing we're going to talk about is if a function is even or odd. An even function has symmetry with respect to the y-axis. Test means I plug in a negative x, and if the original function comes out the same, it has symmetry with respect to the y-axis. Origin, I have symmetry with respect to the origin. You remember, we did this yesterday. Origin, I plug in a negative x and a negative y. If I get my original function, this is stated a little bit differently this time. It says that if I plug in a negative x, which we're plugging in negative x for both of them, if I plug in a negative x and I get my original function, I have symmetry with the y-axis. If I plug in a negative x and I get all signs are changed, I'm going to have symmetry with the, it's going to be an odd function. Sorry, I'll have symmetry with respect to the origin, so it'll be an odd function. So, for example, how are we going to do these four? In a negative x, I'm going to find f of negative x. So that's going to be a negative x squared minus a negative x to the fourth plus 1. So anytime I take a negative number, raise it to an even power, what happens to the number? It's positive. So is this our original function? So what type of function is it? It's even.
How do you know if it's even?
Because if I plug in a negative x, and when I do the math and simplify it, if I come up with the original function, same sign, same everything, it's an even function. That's what the even function symmetry states. Then for b, I'm going to plug in a negative x. So that's a negative x to the third plus a negative x What's a negative number raised to a third power? Negative. And then that's minus x. Look at this function compared to this function. Is this the opposite of this one? Yes. So it's an odd function. All signs have switched. So it's an odd function. Compared to C, when I plug in a negative x, we get a negative x cubed plus a negative x minus 2. This becomes a negative x cubed. This becomes a negative x. And that 2 is negative 2. Is that the original function? Are all signs switched? No. So this is neither. These two changed, but that negative 2 still stayed negative. All right, f of negative x here. This is a little tricky. Well, what do you know about the absolute value of x? It's positive, which means it's also going to be the same as the absolute value of x. So are these two the same? So it's an even function.